Quick. Okay, let's get started. So again, the Schoology quiz is due officially Tuesday at 7 a.m. 5 questions, only 2 attempts. You can do it in class Monday if you want. Some of you jokers are doing it right now. Yeah, you're a joker. Okay, antiderivatives and indefinite integration. Sorry, that says Friday right there. Anti, not as like opposed to. We're not opposed to derivatives, or at least I'm not opposed to derivatives. I hope you're not opposed to derivatives. But anti as in terms of opposite of derivative. Or underivative. So we're going to go backwards today. How else to think of that? It's a Jeopardy day. Like I'll give you the answer, and you got to go backwards and come up with the question. So, needless to say, you got to know all the forward facts right in order to go backwards. Right? You got to know all the derivatives in order to be able to think backwards and work backwards. Okay, we know that if f is 2x cubed, then the derivative of f would be 6x squared, right? Move the power down, increase the power by 1, got it. But, what if we're given that the derivative, okay, so the answer, the derivative is 4x cubed, and we are told to find the function f. So again, this is a backwards question. That's what we're going to be doing all next week, is thinking backwards. So it's like the answer is 4x cubed. We need to take the antiderivative, the underderivative, the go backwards 4x cubed. So you probably can figure this one out just by thinking about it, and that's what a lot of these are. It's like, do you know the rules forward well enough to use them in reverse? So can anybody figure out what the original function was? Who has a derivative of 4x cubed? Heck. Wait, I heard a whole bunch of things. I definitely heard x to the fourth, right? Because the power's got to go down by 1. And that's it, because if I took the derivative of x to the fourth, the 4 would come down and I would get 4x cubed. So that one wasn't too bad to just kind of think about and come up with it. Now what's a little bit tricky with antiderivatives is that there are other options. X to the fourth. I mean, it has to be x to the fourth to get 4x cubed. But what kind of things have a derivative of 0? So if this was x to the fourth plus 7, that derivative would still be 4x cubed. Right? Because the derivative of 7 would go away. Or x to the fourth minus 23. Or x to the fourth minus, 12 pi squared. It would be silly here. But any constant has a derivative of 0. So when we go backwards, you have to throw in this constant. I skipped the line here. Well, that works too. All of those can go there. We can add any constant when we antiderivative. It's called the constant of integration. And so we'll always just throw on a plus c. Whenever we go backwards, we have to never forget to toss this plus c at the end. Oops, you can see it. Because the derivative of a constant is 0, we don't know what the constant was. It could have been anything. So you figure out what your, sort of the main part of the antiderivative is, and then you put the plus c at the end. Okay, a little word about notation here. We denote antidifferentiation, antiderivatives, underderivatives, going backwards with an integral sign. And so this elongated S is what it means, and we'll talk about why it's an elongated S later. Means take the antiderivative of. So we already said the antiderivative of 4x cubed is x to the fourth, but don't forget the plus c. Here's some wordy stuff to think about. We read this, or back up one. If g of x is an antiderivative of f, then the antiderivative of f is g. But don't forget the plus c. The antiderivative of f with respect to x is equal to g of x plus c. Okay, let's talk about some rules for going backwards. And this says no, and it's got a bunch of stars by it. But I'm going to add this to this. You kind of already know. So this isn't going to be new information, these boxes. This is going to be information that you already know, but now you have to process backwards. So here's the power rule. N is any real number except -1. We'll see why that is in a minute. Then the antiderivative of x to the n is x to the n plus 1 divided by n plus 1. Again, maybe it would be helpful if we took the derivative of x to the n. We should have done that first. The n comes down front, and we decrease the power by 1. Right? That's old school. That's easy stuff. If we want to go backwards, then we'll increase the power by 1 and divide by the new exponent. Increase power by 1, divide by the new exponent. And then don't forget the plus c. So some of you are going to memorize this rule. Others of you are never going to think about this rule. You're just going to do it. You're just going to kind of figure it out. Like when you got x to the 4th, you didn't know what the rule was. You just figured it out. And so as we do these problems, some of you are going to be like, I'll just sort of figure it out, people. And others of you are going to be more formulaic, follow the rule people. And either way is okay. Usually the easier ones you can figure out. And if you start getting into fractions and negatives and weird numbers, then it's like, oh, maybe I better go back and think about the rule rather than just the figure it out method. All right, some trig stuff. But again, you kind of already know this. What's the antiderivative of cosine? So what function has a derivative of cosine? And you guys that just did the quiz, this should be fresh in your mind. Sine. But not just sine of x, plus c. You got to put the plus c on there. Okay, this next one's a little bit trickier. The antiderivative of sine. So what function, when I take a derivative, do I land at sine? Negative cosine. Plus c. Antiderivative of secant squared. So like that looks familiar. One of those trig functions has a derivative of secant squared. Tangent. The derivative of tangent is secant squared. Tangent x plus c. Again, this parallel structure going on. There's a trig function whose derivative is cosecant squared. Well, kind of. Negative cotangent. Then a function whose derivative is secant tangent. Secant of x plus c. And then cosecant cotangent, its antiderivative, its backwards would be negative cosecant of x plus c. For these, I would almost say you don't memorize those. If you try to memorize those, you start getting backwards who's got the negatives and who doesn't. And just if you know your derivatives well, then you can come up with these. You guys came up with all of those. I didn't write these down. You told me what to write down for these. So I don't know about starring these. I mean, they're important. But usually, if you know your derivatives well, you can come up with your antiderivatives. A little bit like driving backwards, right? Driving your car backwards is still tricky, but the better you are at driving forward, the easier it is to drive backwards. Looking at people, somebody had an accident driving backwards over there. Usually there's someone who's backed into their mailbox at home. You got to go slow when you're driving backwards, right? Because you're not used to it as much. And so it's the same rules, it's the same car, it functions the same way, but just slow down when you're going backwards. All right, let's do some example problems here. All right, antiderivative of 8x cubed minus 9x squared plus 4. Okay, again, some of you are just going to sort of reason through these. I think I'm going to go a little more formulaic approach on some of these. Antiderivative of x cubed. Let's just take them one at a time here. Well, don't worry about the 8. 8's just along for the ride here. So, antiderivative of x cubed. Increase the power by 1 and divide by the new power. Increase the power by 1, divide by the new power. Minus 9. All right, antiderivative of x squared. Increase the power by 1, divide by the new power. Increase the power by 1, that'd be x cubed. Divide by the new power over 3.
Why did you divide by 2? It should be 4.
What did I do wrong? Yes, I said the right thing. I just didn't. What did I think I'm going to claim my brain did 8 divided by 4 and wrote down 2. I don't know if that's right or not, but that makes my mistake more reasonable. Well, what about this last one? That one is more like figure it out. Like, hey, think about this. What has a derivative of 4? 4x. It's still x to the 0 if you really need to go the formulaic route. Like x to the 0 is the same thing as just 4. So you increase the power by 1 and divide by the new power. But most of the people realize the antiderivative of a constant is that constant times x. Oh, that's not quite finished yet. Plus c. That's a safe stop, but of course the multiple choice is going to finish reducing those pieces. Driving backwards. Increase the power by 1, divide by the new power. Simple enough when it's integers. What should I do first for this next one before I even take an antiderivative? Make it an exponent. So what would the exponent be for the 4th root of x cubed? 3/4 plus 1 dx. Okay, so definitely slowing down on this one. This is like backing up around a curve here. You just really slow it down. Increase the power by 1. 7/4. Divide by the new power. Okay, so I could divide by 7/4, but there's an easier way to divide by 7/4. Multiply by 4/7. I saved myself a little bit of a step there. And then how about the antiderivative of 1? 1x plus c. Number 3. Okay. What is the power for x to the 7th in the bottom? How could I rewrite that as x to some power? X to the negative 7. All right, why don't you see if you can finish that one? It would be plus 24t, 24t squared, plus 9 dt. Okay. Haven't done any calculus yet. That was just the algebra step. Now I can go and do the increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. So there's the answer to number 4. Number 5, same rule. Increase the power by 1, divide by the new power. And then pick on Bailey to see if she remembers what the antiderivative of secant squared is. Good. Tangent of theta, and still a plus c at the end. So again, they're all just backwards problems. You just have to be extra careful and think, and sometimes do a little bit of algebra first, like number 6. So what do you think? Like, that looks like a quotient rule problem. The trouble is there's not a quotient rule for backwards problems. There's not a quotient rule for antiderivatives. So what can I do to get around the quotient rule? Yeah, this one's easy. I can just divide everybody by x squared. I mean, I'd probably do that if I was taking a derivative, because it would make life a whole lot easier. Let's see here. Abby, Takwa, and Jake. Abby, how about the antiderivative of 4x cubed? X to the 4th. Okay, good. Abby did the steps in her head there, the divide by 4, but the 4 is canceled, so yes, x to the 4th. Takwa, how about the antiderivative of 2x squared? 2 over 3x cubed. Yep, increase the power by 1, divide by the new power. Jake, how about the antiderivative of negative 1?
Negative x.
Yes, negative x. Because the derivative of negative x would be negative 1. And then don't forget our plus c. For people who know their derivatives, this lesson should be pretty easy, right? Like, if you know the forward rules, then just slow it down and be careful and put it in reverse, and you'll be fine. Number 7, slightly different type of problem here. Solve the differential equation. Sounds fancy. F prime equals 4x squared, given that f of negative 1 equals 3. Solve the differential equation. What that means is find f of x. Well, they gave me f prime, so to get from f prime to f, I need to underivative one time. So let's underivative both sides, or antiderivative both sides, or integrate both sides. Jimmy, how about the antiderivative of 4x squared? And then go ahead and finish that off for me. Plus c. Okay, so I have f of x, kind of, but I don't have it exactly. I have a kind of an indefinite solution, but I want to figure out what c is. That's why they gave me this piece of information. So I can use that to find c. Use to find c. So if I plug in negative 1, I should get 3. So 3 is the answer when I plug in negative 1. Right, x is negative 1, f for y is 3. So 3 equals negative 4/3 plus c. So it's kind of an annoying fraction to deal with. C equals 3 plus 4/3, which I guess is an okay way to leave the answer. Now let's write our equation. So f of x equals 4/3 x cubed plus, again, if I want to be lazy, or if I'm scared to add fractions, I can just write that as 3 plus 4/3. perfectly acceptable safe stop. A multiple choice answer is never going to look like that because they're going to want you to add the fractions there. Let's see, 3 would be 9/3 plus 4/3 would be 13/3. So, perfectly good, free response, safe stop answer, but you know multiple choice, they're going to clean that answer up a little bit. So the only extra thing for number 7 and 8 is they give you enough information to figure out what C is. Number 8. Solve the differential equation where the second derivative equals sign, given that the first derivative at 0 is 1, and the second derivative, or no, the original at 0 is 6. So if they give me the second derivative, what do I have to do to get back to f? Right, I gotta go backwards twice. I gotta underive twice. So let's underive once. That would get me to f prime. And Ambria, I need the antiderivative, the underivative, the go backwards of sine. What function has a derivative of sine? Close. Negative cosine. Does that make sense? Okay. So negative cosine. And don't forget the plus c. I think before we go backwards again, I think we should use this to figure out what c is. If I go backwards again, right here, I'm going to have a c times x and another c. So like let's find the c's as we go here. So 1 equals negative cosine of 0 plus c. Cosine of 0 is 1, so c equals 2. So f prime of x equals negative cosine of x plus 2. Okay, so that's my go backwards once process completed. Go backwards once, you get the C, you fill things in, you figure out what C is, and then you realize, wait a minute, I'm not done, I got to do that whole process one more time to go from f prime to f. So let's antiderivative again, because the antiderivative of the derivative, this is sort of like when you square root a square on both sides, because they just cancel each other out. An antiderivative of a derivative gets me right back to f of x. Then on the other side, Autumn, I've got to figure out what function has a derivative of negative cosine of x.
Sine of x?
Sort of. The derivative, or the antiderivative of cosine is sine, right? Because sine goes to cosine. So what would it take to land at negative cosine?
Negative sine.
There you go, negative sine. Let's just pick on different people here. Addie, how about the 2? What is that? 2x. And then this is, I think this is why people forget c maybe, is like it comes out of nowhere, but forget the plus c. And then we'll use f of 0 equals 6. So the answer is 6 when we plug in 0. Negative sine of 0 plus 2 times 0 plus c. I would say they were pretty kind to us there, because what's the sine of 0? And 2 times 0, 0. And so c equals 6. So let's write our final answer all together here. F of x equals negative sine of x plus 2x plus 6. I guess the only thing that's sometimes confusing for students in this one is that, like, there's a C when we did this, and there's another C over here. Those are different C's. Now, as long as you find the first C first and like plug it in and fill it up, then you're done working with C and you can introduce another C. If it really bugs you, then you could say the first one is C1 and just label all of those C1. And the second one is C2 and label all of those C2. But if you're going one step at a time, it's fine to use C because like you figure out what C is, you close that up, and then you introduce another C and go again.
Will there be a scenario where they won't give you the both derivatives answers? So, like, for example, like, would it give you f of 0 for one of them?
What they could give you, so that's a good question. They have to give you two pieces of information, right? Because you got two variables in here. They could do it where they give you two f's and not an f prime. That would be a little bit tricky because you'd have to carry this C. You'd have a C1 there instead of a 2. And so then you would have to call them something separate or else you'd definitely get confused. So they have to give you two pieces of information because you're going to introduce two variables. But it doesn't have to be a first derivative and a original. That's the easier way to do it. But they could get tricky and give you two things later. Okay, so that's it for notes for a few days. Today we're going to do worksheet 1. Monday we'll do worksheet 2. Tuesday we'll do worksheet 3. But there'll be no new notes on Monday or Tuesday. As you might guess, this is pretty important, being able to drive backwards. So like this is just how to drive backwards. Now let's spend a few days driving backwards. Without any new information, let's just get in the car, put it in reverse, and be super careful as we go.